Alright, so in this video, we're going to be going over the washer method, okay? So in the last video, we talked about the disk method, and if you don't know how to do that yet, you don't know what that entails, then definitely go check that out before learning the washer method, because you're going to need it here. Okay, so just a brief review of what we did for the disk method, okay? So we had a graph, let's say we have y equals rad x, okay? We took the area under this curve, alright, and we revolved it around the x-axis. We found the volume, okay? So we did something like that, and we got something like this, okay? Great, so now we do our cross sections, and we're gonna get disks, right? We get circles, okay? But now, what happens if I have that graph again? What happens if I have that graph that looks like y equals rad x, and I want to put another line here, and I want to find the area between the two curves right here, and I want to rotate that around the x-axis, all right? So when you rotate that around, you get a washer, okay? So, and by that I mean you get washers as cross sections, okay? So you're going to get washers because you now have a outer radius, right? That's going to be the distance from here to the center, and you all have an inner radius, okay? That's the distance from, well, let's say the inner part to the center, okay? So now your cross sections are going to be different because you have two radii to worry about. So your area is going to be different, right? It's not going to be that whole disk because there's a piece missing right in the center, okay? Alright, so here is how the equations are going to differ, okay? So in the disk method, we just did our area of the disk, right? Because we had circles. So we had our area of the circle, and that was, of course, pi r squared. And then we take the volume of that, right? Because we're rotating that about the x-axis, and our cross-section is a disk, but now we need to integrate that along the whatever axis, okay? And that's adding up all those little infinitesimally small areas, okay? And that becomes a volume, okay? So now, we have our disk, and we need our washer, okay? Well, our washer has two radii, as I mentioned before, okay? We have our first one, which is our big R, right? Our big R right here, okay? And that is the distance from our outer point to the inner part, all right? And that's R. And then we have our little r, okay? And our little r is going to be the distance from our smaller circle into the center, okay? And that's your little r. So now we just need to be able to find what that r squared, the big R squared and the little r squared are, and that's it. That's literally the only addition with washer method. All right, so let's do some examples. All right, so here's our first problem here, okay? We want to find the volume of a solid given by the region enclosed by the graphs y equals x and y equals x squared, all right? And we want to rotate this about the x-axis, all right? So what's going to happen when we rotate this about the x-axis? Well, we're going to get cross-sections, right? We're going to get cross-sections of this solid that are washers, okay? So all we have to do is find the area of a washer, okay, of the washer at any point on the interval here. And then we're going to integrate, okay, because we're going to add up all the cross sections to get a volume, all right? So the first thing, of course, find the area. So our area is equal to pi times big R squared minus little r squared, right? And now we need to find what our big R squared and our little r squared is. Well, all right, this one's actually not that bad, okay? Our big R is going to be the distance from, well, it's the outer point to the inner point, all right? Or sorry, the outer point to the center, all right? And that's going to be just the height of this graph right here, okay? Well, what's this graph? That was y equals x, all right? So we are integrating with, in terms of x, okay? we are going integrating from 0 to 1 here, okay? So we can just write this as x, okay? So we know that distance is y, but in this case, y equals x, so we know that we can put an x in there, all right? So area is going to equal pi times, it's going to be x squared minus. All right, now we need a little r squared, okay? And that's going to be the distance from this curve to the x-axis, all right? And what is that? Well, what's that graph, all right? That graph is y equals x squared, okay? So we know that distance is y, but what is that y standing for in this case? Well, that y is going to be x squared, all right? Because that's our graph that we're looking at. So that's going to be x squared, and that's of course going to get squared. All right, I already squared the x for the big R there. Okay, so great. We know that our area is pi times x squared minus x to the fourth. Okay, now we need to go to our next step, which is to find the volume. Okay, how are we going to find the volume? Is to integrate now. All right, what's our bounds? Well, our bounds is going to be from 0, right? This is our 0 point. And since we have 1 comma 1 here, our x is 1, so we know that this point is 1. All right, so we have from 0 to 1 of, well, we're going to have pi x squared minus x to the fourth dx. All right, we're going to pull that pi out, and then we can integrate. So we get volume equals pi. All right, then we can integrate that inside there. All right, we get x cubed over 3 minus x to the fifth over 5. All right, and we're evaluating that from 0 to 1. All right, well, when we have our 0 part, we know that's just going to be 0, right? We're going to get a 0 over 3 minus 0 over 5. We don't really need to include that. All right, so let's just plug in 1 and call it good. So we get our volume is equal to pi times, well, we get a 1/3 minus 1/5. All right, and we need to figure out what 1/3 minus 1/5 is. Well, if we get common denominators here, we're going to get, it's going to be a 5 over 15 minus a 3 over 15, which is equal to pi times 2 over 15, which is equal to 2 pi over 15. All right, so just a little quick recap there. We had to find our outer radius and our inner radius, all right? Our outer radius was the distance from our y equals x graph to the x-axis, and the little radius was our distance from the y equals x squared graph to the x-axis, all right? And we just plugged that in, we integrated, we found our answer, all right? All right, so now we have the exact same problem, but now we're rotating about y equals 2, okay? So y equals 2 is going to be up here. So when we get our cross sections here, all right, our area is going, or our cross sections first, our cross sections are going to kind of look like this. All right, and now we need to find our respective radii. Okay, so we have our area, okay, that's going to equal pi times big R squared minus little r squared. And what's our r's going to be? Okay, well, we have big R first, okay? And big R is going to be the distance from our farthest graph to the center point, okay? And what's that distance going to be, all right? Well, if we're trying to find that distance right there, what are we starting out at? Okay, well, we're starting out at y equals 2. All right, so let's say 2. Okay? And what's going to give me that distance? Well, if I subtract the distance from this graph to the x-axis, so if I subtract that very small distance right there, that's actually going to give me my distance from the y equals 2 line to my curve. All right, and what is my curve? Well, my curve is x squared. So I can do 2 minus x squared, and that's going to give me this long stretch right here. All right? And what about little r? All right? So if that just, what I did just confused you, don't worry, because we're about to do it again. All right? So now we're trying to find the distance from our inner or our closest graph to the center point, all right? And we can start off with 2 again, all right? So we have 2. So now, if RE was equal to 2, then our radius would be this whole length right here, okay? From the center point to the x-axis, all right? We know that's not true. So we have to subtract the extra distance here, okay? We have to subtract the distance from the graph to the x-axis. Because if I subtract this little distance in red from the whole portion here, okay, then I'm going to get this, the distance in black. And we know that that distance is x, all right, because we have that graph y equals x. So now we get our respective radii, we can plug that in and find our area. So area is going to equal pi times what's big R squared? Well, we can just plug in 2 minus x squared and square it, and then we have our little r squared, so we have 2 minus x, quantity squared. Alright, so when we FOIL this out here, we are going to get that our area equals pi times, well, we get a 4 minus, we have a 2x squared minus 2x squared, that's going to be minus a 4x squared, then we're going to get plus x to the 4th. Alright, and then we're also going to get a minus, and we have a 4 minus, we're going to get a minus 4x here, and we're going to get a plus x squared. And that's all going to get squared. Oh, no, sorry. I don't know why I put that there. Alright, so now we can just combine like terms here, and we will end up with our area. Alright, so this becomes a minus, we take this parentheses away, minus plus minus area equals pi times 4's cancel out, we get a negative 5x squared, we get a plus x to the 4th, we get a plus 4x. Alright, and now we're going to integrate with that. Okay, so our volume is going to equal the integral from 0 to 1 of this. Okay, so we can already pull that pi out, honestly, if you want to. Pull that pi out, and we're going to get x to the 4th. I'll reorder this from highest power to lowest. Alright, so we get that. Alright, great. So now we need to just integrate. Our volume is going to equal pi. Integral from, oh, nope, not anymore because we're integrating. We get x to the 5th over 5 minus, well, if we do this here, we're going to get a x cubed from 5 over 3 x cubed. And this is going to be plus 2x squared. And we're going to evaluate that from 0 to 1. Alright, when we do our f of b minus f of a, when we evaluate this integral, our 1's going to give us something, but our 0 is not, so I'll just do the 1 for now. Our volume is going to equal pi 1/5 minus 5/3 plus 2. Alright, and then you just have to figure out what that is going to be. So we'll get a volume is equal to pi times, if we get common denominators here, let's get a common denominator of 15. We'll get our 3 over 15 minus, so we get our volume of pi. We get a negative 22 over 15. We add here, we're going to get 8 over 15. So we're going to get 8 pi over 15. Alright. I like to show this algebra work because, honestly, even though you're calculus students, it happens still to get tripped up with the algebra, okay? You know, you might do a negative where there should be a positive. That's kind of the most frequent mistake. So I definitely just wanted to show that quick, alright? So that does it for this problem, but we have one more example before we end the video. Alright, so what am I going to do if I'm rotating this graph now about x equals negative 1? Okay, so this is going to be the other case you're going to get. It's probably going to be, I mean, it's not like none of this is extremely hard or, you know, mind-boggling stuff, but this will probably be one of the harder cases that you get, okay? So we have x equals -1 right here, all right? And we want to now rotate a different way. So we're rotating this way now instead of this way, all right? So we're going to rotate and get something that looks like, this is going to be really bad, but just stick with me here. So that's kind of what our cross sections are going to look like. Or you're going to get a disc. Imagine that was in 3D, I guess. Not a great drawer myself, so don't judge too much. All right. So now we need to find our little r and our big R. All right, for our area equation. So what is that going to be? All right. Well, first off, realize that my r and my little r, all right, those are going to be horizontal distances. So let's do big R first, okay? That's going to be from here all the way into the center point right here, okay? And that's a horizontal distance, okay? That's not vertical. So now we're doing this in terms of y and not in terms of x, okay? So what's the distance? The easiest way to do this, to find this distance, okay, is what's the distance from the axis that we're revolving around to the y-axis, okay? And that's going to be, well, that's going to be 1, okay? So we'll start off with a 1 for our r, all right? And then what's the distance from the y-axis to the curve, all right? Well, that's going to be x, right? That's going to be whatever x is, all right? And since that curve is y equals x squared, we're going to need to solve for x, okay? So we have our y equals x squared, all right? We solve for x equals rad y, okay? So that distance is going to be rad y. So we get our r of 1 plus rad y, okay? The reason, if you're confused, why I said, oh, the distance here is x, is because it is, okay? Think about it. The distance, whatever your x coordinate is along your, you know, for any point along that graph, okay? That's your distance. Your horizontal distance from the y-axis to that point, all right? That's the whole idea behind an x-coordinate, okay? So now we need to find the little r, okay? We need to find the small radius, which is going to be from our point right here to the center point, all right? That's going to be the same thing. I guess maybe it'd be easier to draw it like, and instead I can draw it right here. All right, from here to in. All right, same thing, same distance. All right, we're still gonna have that 1 there. Okay, we're still gonna have 1. Okay, that's gonna be the distance from the axis we're revolving around to the y-axis, and then we have that extra distance there. Okay, that's still going to be x, but we're using a different curve this time. Our curve now is y equals x. So when we solve for, well, we actually don't have to solve for x because x has already been solved for. So x equals y, our little r is just going to be 1 plus y, okay? Now we can plug that all into our equations and, our area equation, and we're going to find what our area is actually going to end up being. So our area equals pi times, we have a 1 plus rad y quantity squared minus 1 plus y squared, okay? Now we're going to FOIL this out. We're going to get area is equal to pi times 1 plus 2 rad y plus y minus, we're going to get a 1 plus 2y plus y squared. All right, and then we are going to combine like terms here. We take away these parentheses here. This becomes a minus 1 minus 2y minus y squared. The minus 1 plus 1 is going to cancel out. We keep the 2 rad y and the y squared, so we're going to get area equals negative y squared. The plus y minus 2y is equals a minus y. And then we have a plus 2 rad y. Alright, oh, and of course, like I almost forgot, we have our pi here. So area equals pi times this. Alright, so now we're going to have to integrate. Okay, so our volume, I probably have room here, so we'll do our volume equals our pi times the integral. What's our bounds going to be? Okay, well, our bounds is going to be the distance from now on the y-axis, okay? So our distance from, it's going to be 0, okay, that's going to be our bottom one. All right, that's where both of the graphs are originating from. And it's going to end at 1 because that's our top point. So it's still going to be 0 to 1. It's just that now these are y coordinates and not x coordinates. Okay, so now we can plug in our negative y squared minus y plus 2 rad y. We have a dy on the end. All right, we need to integrate now. So we're going to get our volume equal to pi times negative y cubed over 3 minus y squared over 2 plus, if we integrate this, we're going to get 4/3, and we're going to get a y to the 3 halves. All right, and we're going to evaluate that from 0 to 1. Okay, again, when we plug in 0, and of course this is not always the case, you guys know this, but we're not going to get anything when we get 0, because we get a 0 over 3 minus 0 over 2 plus 4 over 3 times 0. It's just all going to be 0. So honestly, I don't even feel like writing that term down. We get a volume equal to pi times, we get a negative 1 over 3 minus 1 over 2 plus 4 over 3. Okay, that was just plugging in 1. And now we find our common denominator and get our answer. Okay, so we have a negative 1/3, a negative 1/2. All right, we can rewrite that as, we'll say pi times, well, we're going to get a negative 2/6 minus 3/6. And when you get your 6 there, that's going to be plus 8/6. Okay, and that is all equal to, well, we have a negative 5 over 6 plus 8 over 6 is going to be 3 pi over 6, which is just pi over 2. Okay, so that's all going to be equal to pi over 2. All right, and that is going to be your volume. Okay, so there's 3 solid examples of using the washer method. That's all you're really going to see, and the hardest part is just going to be finding what your 2 respective radii are, okay? And then you're set, really. It's just going to be getting your area down, which is finding your radii, and then integrating to find your volume, okay? So that does it for this video, and I'll see you guys in the next one.